Hey guys, welcome to Transistor Therapy. In this video, we'll discuss about the Arduino functions, Arduino arrays, Arduino strings, and the Arduino time-related functions. Okay, so first we need to understand what a function is. Well, a function is a specific task or a job to be done either a single time or multiple times according to the user's requirement. So let's look at the declaration of a function, and its syntax goes like this. First comes the return type, which specifies the data type of the result returned to the caller of the function. Well, the return data type can be any of the data types which we have discussed earlier in our previous videos. The next comes the name of the function, which is straightforward, specifies the name of the function, which is used when we are calling the function. Well, inside the parenthesis is the list of the arguments or parameters passed in the function, and after the braces starts the body of the function. So let's take an example of a function named compare, which compares two integer variables a and b, which are passed as the parameters list inside the parenthesis, and the return type is boolean, and when we enter the braces we have the if conditional statement where if a is less than b, the result is returned as true, or else the result is returned as false. Arduino arrays. So what is an array? Well, an array is a consecutive group of memory locations which contain multiple data of the same data type. To refer or access any particular element in an array, we first specify the name of the array, followed by the index of that element in an array. Well, the index is same as the position number of the element in the array. So here we see the syntax of the basic declaration of the array. So the type specifies the data type of the elements in the array, and this is followed by the array name, which specifies the name of the array. And what we have to look at carefully over here is the array size, which specifies the size of the array, and it is mentioned in the square brackets. So let's take a look at some practical examples on how to initialize the array. So in the example 1, we have initialized the array with the use of looping statements. So here we have declared an array of size 10 and the data type as integer, and under that we have a for loop statement which is given as int I equal to 0, which is the starting point, and its limit I less than 10, and I is incremented each time it goes through the loop. And inside the body of the loop we have a of I equal to I. Here the value of the looping variable is put into the appropriate position in the array, or the index in the array. In the example 2, we have a constant integer array size equal to 10, and we have an integer array a declared as its size as equal to the array size and initialized as the values given up from 0 to 9, which has 10 values, which is exactly equal to the array size value. Types of arrays. Well, there are two types of arrays, single dimension and multi-dimension arrays. Let's understand each of them with the help of an example. A single dimension array has one size definition square bracket, which is probably just rows, and a multi-dimension array has more than one size definition square brackets, which is both rows and columns, and probably so on as the dimensions increases. If the number of elements in the array are less than the actual size of the array, then zeros are filled till the last index of the array, and the previous point which I have told will be very important to be noted. Let's now look at how the arrays are passed to the functions as arguments. First, we specify the array name without the size in the brackets, then give the array size as another argument to the function. So in this example, we have a function named as int total, and in the brackets, the parenthesis, we have an input array B, and the size of the array is array size variable, and inside that we have a result sum, which is the int data type, and we have a for loop where the elements of the input array are added and put it into the variable sum, and that sum is returned back to the calling function. Okay, so let's now take a look at the strings used in the Arduino. So what are strings? Well, the strings are used to store and alter the text. This text may be used to display on the LCD or in the Arduino serial window, and it can also be used to store the user input from an external component such as a keyboard. Okay, now let's see how strings can be declared and initialized. So number 1, string character arrays. So as we can see in the example number 1, the string is declared as the array of characters element by element. So in the example we can see that my str is a character array string of data type char, and its size is 6, which includes the text hello plus at the end it includes a null termination character denoted by 0. This null termination character, when read by the compiler, denotes that the end of the string has occurred. Number 2, string character array literals. Well, here the string to be displayed or manipulated is specified inside the double quotes, and here in the example we can see that a my string array or my string literal of data type char is specified with the text hello as its value, and here the compiler, when it reads my str, it calculates automatically the size of the string, and also it adds automatically the null terminating character. Number 3, string objects. Well, let us see what an object is. Well, an object is a physical representation of a construct, a logical construct, that contains both the data and the functions. Well, a string object can be created just like any other variable and be assigned a value or a string. Well, the string object contains functions, or which is properly called as methods in the object-oriented programming concepts, which operate on the string data contained in the string object. These objects and classes are supported in languages which support the object-oriented programming design. Okay, in this example, we can see the string object myStr created like any other variable and assigned a memory, and it is assigned a value of hello string. So next up, the Arduino time-related functions. Number 1, the delay function. The delay function works in a pretty simple way. It takes an integer argument, and this argument specifies the time in milliseconds. When the compiler encounters this function, it delays or pauses the execution of the program for the specified amount of time which is given in the argument. Number 2, delay microseconds function. So this function is also similar to the previous one, except the fact that it takes an integer argument which specifies the time in microseconds. Number 3, the millis function. This millis function returns the amount of time lapsed since the beginning of the program execution in milliseconds. Number 4, the micros function. This is similar to the previous function, except the point that this function returns the time lapsed since the beginning of the program execution in microseconds, and the return data type of both these functions is unsigned long. So that's it for this video, guys. Hope you all understood the concepts covered in this video. If you had any doubts related to this video, please post it in the comment section below. And please don't forget to like, share, and subscribe. Adios, everyone.